Hey, and welcome back to our Flask application tutorial series. In this video, which is video 4, I'm going to show you how to Dockerize your Flask application. So basically how to create a Docker container that we can run our Flask application in. So for those of you that might be a little unfamiliar, Docker is a platform where developers, DevOps folks can basically, through files that contain commands, build, deploy, run, update, maintain these containers. And a container is basically, it's not really a virtual machine, but you can sort of think of it as like a little virtual machine that's running all of the application code that you've written. So, for our purposes, it'll be our app.py and blueprints and whatnot, and then a basic operating system and whatever associated dependencies are needed for your application. So you package this all up and it creates a container whenever it's in execution. So yeah, let's get into it. Okay, so back here in Visual Studio Code, the first thing we're going to do to Dockerize our application is to create a new file, and we're going to name it Dockerfile. And this file has to be definitely a very specific name. I'm not sure why that didn't work. Let's do it again. Dockerfile. So there we go. So there's our empty Docker file. So in this Docker file is where we're going to put commands for Docker to know how to firstly construct what Docker calls an image, which is sort of like a blueprint, but not like Flask blueprints. It's just a structure for what will ultimately be a container. So the first thing we're going to do is we need to tell Docker what our base image is going to be. So we're going to, you could start totally from scratch, but we're going to use an image called, so we're going to say from, and we're going to use the image called Python 3.9-Alpine. So this is an image that Docker will go out and grab that already exists on this site called Docker Hub in any event. So it's basically a very small Python runtime based on Alpine Linux. Okay, so then the next thing we're going to do is we're going to need to set up our working directory. So I'm going to create a directory using the run command. So the things that are in red are kind of the commands of the Docker file. mkdir, and I'm going to put mine at user source app. Okay, so if you're somewhat familiar with the terminal or command prompt, mkdir is basically making a directory or making a folder. So then we're going to set the working directory. Sorry. Oops. Oh my. Workdir to that directory we just created, user source app. Okay, so a working directory is basically the source of information, the source of code, where whenever you'll see later, we're going to actually have a command to start the application. And in the absence of providing a path for the Python file that command is going to execute, it would look in the working directory. So it's sort of like the home for the application. Okay. Next, what we're going to do is we're going to copy all of the code that's in our current directory. So that's going to be the folder that has the Docker file in it. So that's going to basically be all of this. We're going to copy it into that working directory. So user source app. Okay. Because our application is running on port 4000, we're going to go ahead and expose that port. Okay. And then we are going to tell tell Docker to install whatever Python dependencies we need inside the container. But before we can do that, we need to make a file that contains those dependencies. So I'm going to make a new file, and it's going to be called requirements.txt. Okay, so in this file, the only Python dependency we need is Flask. So for now, we'll just put Flask. We may add some later in a future video. All right, so in order to execute or to have Python install the Flask library, so we're going to say run and then pip install -r requirements.txt. Let's see, did I spell that right? Yep. Okay, so the run command is basically executing some command, as you saw the make directory up here, some command inside the image. And so pip is the sort of Python package manager. So whatever lines exist in this file, it's going to go through and it's going to basically say pip install Flask, and if there is, Flask MySQL, pip install Flask MySQL, and so on. All right, so then we're going to run the application. So we're going to have command, and we're going to have some brackets. We're going to say what command. So we want to run our application using Python, and so the name of the Python executable is Python, and then the argument to Python is going to be app.py, which is the application we have. Now, this is going to be app.py that's been copied into the container from this statement up here. Okay, so we'll go ahead and save that. And so from this stage, what we can do is create our image. So we can kind of use this file to create a blueprint for what will ultimately be our container. So in our terminal, our command prompt, let me clear this out. We're going to say docker build -t. T is for the tag, so what we want this image to be named. I'm going to name it Flask image, and I'm going to call it dot. Not call it dot. I'm going to call it Flask image. The dot represents telling Docker to look for a Dockerfile with the commands in the current directory. So let's go ahead and execute that. It's doing some things, installing, and there you go. So we have our Docker image, so we can start our container. So right now there's nothing running, so we don't have a Docker image, there's no Python application running, but we can go ahead and start our image using the docker run command. And we're going to map host port 4000 to container port 4000. So what the -p is basically a port mapping. So the first number is the host port. So this will be the number that you would go to in your browser. Second number is whatever port you need to have access to inside the container. So our application, as we know from app.py, is running on port 4000. So it's listening on port 4000. All right, so we're going to say docker run -p 4000:4000 to do our mapping, and then we're going to tell it the name of the image or the tag of the image that we want to use, and we called it Flask image. So we'll say Flask-image. Okay, and then it's going to do some things, and you should see something that looks kind of like this. If you see error messages, things that make you think it's errors, then you'll have to go and fix them. But if you'll notice, this looks very similar to when we just ran the application in VS Code by clicking the play button. All right, so if I go into my browser, I should be able to stick it 4000, and let's just go there, and that's not working. So the reason this isn't working is because we are going to 127.0.0.1:4000. So that's on your host machine, like I don't know, your laptop or desktop or whatnot. But the container doesn't know to specifically connect with that URL. So we have to go back to our code and add one line in our app.py. So we're going to add host equals. Then we're going to do 0.0.0.0 so that it will accept connections from any URL. So the problem, though, is our container doesn't, it has a copy of the original code. So what we're going to need to do is rebuild our image. And then rerun our container. So if we then go back to our browser, we get the application. So without that extra host equals 4,000, I'm sorry, host equals 0.0.0.0, the server, so the application, would not accept any connections from anything but inside the container, even though the port was exposed. So this is what allows us to have, you'll see this command right here, or this statement. That's how you kind of know that it's listening for connections from something more than localhost. Okay, so now that we have our Docker container running, I'm going to go ahead and stop it by hitting Control-C. Now that we have that set up and we kind of have some confidence that it's working, we're going to need to do a little code reorganization. So in a Dockerfile, that only sort of prescribes the structure for one image and then ultimately one type of container. So, but ultimately in our application, we're going to have the application container as well as, let's say, a MySQL container. We're not going to run MySQL inside the application that's running the Python application. So, sorry, I feel like I said application 100 times. So we're going to need to reorganize our code a little bit. First thing I'm going to do is I'm going to collapse these. And I'm going to come to the general. I'm going to add a new folder. Okay, and I'm going to call it app code. All right, and so I'm going to put everything else that we've created inside that folder app code. Include, so our blueprints, the Docker file, the requirements file, everything. So if you think about it now, app_code represents everything for the Python side of our application. So now what do we do? Okay, so we're going to use a tool that comes with Docker Desktop called Compose, Docker Compose. And Docker Compose allows you to structure, to basically orchestrate a collection of containers all at one time in one application, in one sort of unit, if you will. So to do this, I'm going to create a new file called dockercompose.yaml. So it's yet another markup language. It's a YAML file. And first thing we're going to do in this file is let it tell it what version of the compose syntax we're using. So it's going to be version 3.9. All right. So one of the things you do in a Docker Compose is you identify or enumerate a set of services. Right now we're only going to have one service. It's just going to be our application. So we're going to say services. Okay, and then we need to indent, and then we're going to give our service a name. So I'm going to call it Python app, semicolon. Now we're going to indent again. We need to tell it how to actually create this particular image. So we're going to say it's going to be built based on whatever's inside the app code folder. So build : app code / So this statement's actually going to make use of the Docker file that's inside our app code folder to build the image and ultimately spin up the container. Okay. And then we're going to do our port mapping here rather than at the command line. So we're going to say ports, and we're going to map port 4000 to port 4000. Okay. So we have that. So we're at Flask sample. Still, we haven't moved inside the terminal, but you can see our code is reorganized now. So let me clean things up. All right, what we're going to do in order to build the image is Docker compose build. So this is similar to the way we built the image before. And then we're going to do Docker compose up, which is going to spin up the container. You see the same set of messages you were getting before, but it has this indication before, which is that this sort of prepends it, that indicates where the information is coming from. So it's coming from Flask sample. That's because we're in Flask sample folder. And then the name of our service is Python app. And we have one container of Python app running. All right, so going back to our browser, if I refresh, it should still be working. Refreshed a few times. So if I come back to my code, you can see it is recognizing the request from the browser. All right. So now we're at the point where every time we modify our code, so if I come back to code to app.py and I change the base route to, let's just say, another string, this is super cool. Then when I save it, one might expect that, okay, well, if I go back to the browser and I refresh, I should get that new string. But that's not what's happening, because remember, in our Dockerfile, we made a copy of whatever's in the local folder, so all of this stuff, into the image, into the container. So it doesn't, when I update the code in my local system, so on my host system, it's not going to update inside the container. So what I need to do is basically map the folder that contains my code from my host system to inside the container. And the way I'm going to do that is with a volume command. So we're going to mount a volume. Think of it as basically one folder that lives inside the container and on your host machine. So we'll say volumes, and then we'll give it a mapping. So ./app code, and we're going to map that to inside the container, the /user/source/app, which is the working directory. Now I can't take out the copy from the Dockerfile because I need that for the requirements.txt to be able to install. I could make a more specific copy statement in the Dockerfile, but for now I'm just going to leave it the way it is. All right, so I'm going to bring the containers down. All right, I'm going to go ahead and remove the containers by typing docker compose down, because we're going to spin up new ones. All right, so it kills the containers, and you'll notice there's also a network object that's removed also. Whenever you use Docker Compose and you have services inside of them, it builds basically a virtual network, so any services can sort of communicate on that virtual network. We only have one service right now, so it's not super important. Okay, so let's go ahead and build our container. So build our image, Docker Compose, build. Okay, now we're going to do Docker Compose up. So let's go test our application. So if I refresh, I get the new string. This is super cool. But if I come back to my code and I type, this is, let's just add really, really super cool. Notice when I save it, the application says it's being updated, much like we saw before we introduced Docker. So if I go back to my browser now and I edit it, you'll get the new file, or the new content. So what we've done, just to recap, is we created a Docker file that contains some commands to create an image and ultimately a container that can run our Python application. It's based on this Python 3.9 Alpine Docker image that's sort of available online. You don't need to download anything. Docker will automatically download it if you don't already have it. And then we also created a requirements.txt file, which has whatever Python requirements we need. And that's going to be used by pip to install those requirements. And then we're using this command to actually execute the application. We made that work. And then we put all of our code for our application into a new folder called app code, because we wanted to use Docker Compose to spin up the actual application container, because later we're going to add another service for MySQL. So there you have it.